The question is about two ships traveling in different directions. In fact, perpendicular directions. One is going westward and the other one is going northward. Initially, they are separated by 100 km. Fine. And their speed is 10 km per hour. These are data. And you need to find out the minimum distance between them. Okay. First of all, whenever you have questions like questions which contains directions like north, south, east, west, etc., it's always better to assign some direction in solving this question. So normally I do like this: north in the top page, south opposite, and west here and east here. Now visualize: ship A is moving westward and ship B is moving northward, but the separation between them is 100 km. So if I mark ship A here and ship B must be here, okay, in the beginning, because that's only then ship B can move southward, okay, ship B can move northward, this is moving northward and this one is moving westward. So what is the initial distance between them? The initial distance will become 100 km. Okay, and their speeds are the same. Since their speeds are the same, what will happen is that after like say after 1 hour, what is their position? After 1 hour, what is their position? After 1 hour, both the ship will move, see, 10 km in 1 hour. So after 1 hour, this will be here, 10 km. This will also be here, 10 km. Now if you look from ship B, see this one is B and this one is A, keep that in mind. If you look from B to A, what is the direction? Initially when we looked from B to A, the direction was this thing, but now the direction changed. The direction changed like this. Okay, initially the separation was 100 km, now the separation changes, the distance between them changes. Now this process will continue. After some time, ship B will reach here. At that point, ship A will also move the same distance. So both of them will move like this one. Then this process will continue like this one. After some time, after exactly 10 hours, ship B will reach the initial position of ship A, and ship A will move westward, and that will be 100 km, the initial separation. Fine. So initially the distance was 100. After some time again this distance will become 100. So this is how actually they move. During this period the distance will decrease, then it will increase. So there is a minimum distance between them. This is what we need to calculate. So once more, to understand the problem, there is the ship B here at the south side and ship A here on the north side, and ship A, this is ship A, this is ship B. Initial separation is 100 km, and they start. Ship A will move in this direction and ship B will move in this direction, and after some time ship A will reach here, ship B will be here, distance will become 100 km. Initially the distance was 100 km. Okay, and if you join the positions, what you see is that initially the position, this was the initial position, and after some time you can see the positions will change like this. The positions changes like this. This is the direction in which they will appear from each other. The direction in which they will appear from each other. Okay, and the distance initially was 100, finally 100, then the distance must be minimum in between. After that you can see, after that the distance will increase further. Okay. Now to solve this problem, it's better to take the relative velocity of ship A with respect to ship B. The relative velocity of ship A with respect to B is a vector which is given by subtracting velocity of B from velocity of A. VA minus VB. This is also equal to addition of velocity of A to the negative of velocity of B. If you want to subtract B, VB, then you simply add negative of VB. Fine. This is the technique that we are going to use. This will easily give you the concept of the direction, and then that will easily make you calculate the answer. What is velocity of A? Velocity of A, VA, is a vector, and that is given in the question as 10 km/h. That is the magnitude, and the direction is west. What is velocity of B? Velocity of B is a vector having magnitude 10 km/h, but direction to the north. What is negative of velocity of B? That is another vector with the same magnitude 10 km/h, but direction is opposite to negative of north. Negative of north means south. So what you have to do is that use parallelogram law and add these two vectors. Add these two vectors, VA and minus VB. That will give you the relative velocity of A with respect to B. Let us do this graphically. First you draw velocity of ship A, that is towards the west. So you can just draw a vector in this direction. This is the velocity of A towards the west, and its size must be 10, proportional to 10. Then draw the negative velocity of the other ship B, and that we know it is to be drawn towards the south. This is negative of velocity of B. Now add them, and when you add them, you can say you can create a parallelogram like this one, and the parallelogram effectively become a square. It is a square because both the sides are equal, and the diagonal gives you the resultant. Okay, so what is the diagonal? The diagonal will be drawn from this point in this direction. So this is the direction of the relative velocity. What does it mean? It means that if B is watching A, this is the direction in which the ship A will appear to be going for every person in the ship B. For ship B, this is the relative direction of ship A. So the meaning is that the motion of ship B will not be experienced by that observer, but he will see that the ship A is going in that direction, along that direction, not west, but southwest, 45 degree. The concept is simple. This is how ship A should travel if ship B is at rest. Suppose ship B is here at rest, then to produce the same effect, ship A, which was at 100 km away from B in the north direction, that should travel in this direction. Only the same effect is produced. Now you can see that initial distance is 100. After some time also it is 100, but in between the distance decreases, and this becomes the shortest distance. This distance. So this is the direction of relative velocity. The first diagram gives you the direction of relative velocity, and you can see that the magnitude of this one is 10, magnitude of this one is 10, so this will give you 10 root 2. So if you are asked what is the relative velocity of A with respect to B, answer is that it is 10 root 2 km/h, but southwest direction. Now let us draw the relative path of A. Okay, for this let us mark ship B here and the initial position of ship A here, and the distance is 100 km. Okay, so if you join this thing, that will become 100 km. Now relative to ship B, that means if ship B is at rest, then A will move in this direction at 45 degree. At 45 degree. Correct. So this angle will be 45 degree. Now where is the shortest distance? Shortest distance can be marked from B to this line. This is the shortest distance. This is what we need to calculate. So let us take this point as C. So in the triangle ABC, AB is 100. So what is BC? BC is the opposite side of this 45 degree. Okay, so we can say, we can define sine 45 degree. equal to, what is sine 45 degree? Opposite side is BC divided by hypotenuse is AB. We want the shortest distance, which is nothing but BC, that is nothing but AB sine 45 degree. AB is given as 100 into sine 45 is 1 by root 2. So the minimum distance is 100 by root 2, or this is also equal to 50 root 2 kilometer. Now the final answer. It is asked what is the shortest distance. The shortest distance we calculated as 50 root 2 kilometer. And what is the relative velocity of A with respect to B? Answer, that has got a magnitude of 10 root 2 kilometer per hour. 10 root 2 kilometer per hour, and the direction is southwest.